So, welcome everyone to our channel OnlyPhysics JEE Grad. This is the video where we will discuss JEE Advanced PYQs from the chapter Kinematics. This will be our last video, which is part 3. Other two videos are on the channel. Do check that out. So, in the last video, we have studied three topics. One was relative velocity, second was motion in 2D, and third was projectile, right? So relative velocity, motion in 2D, and projectile motion. But in the projectile motion, we have only studied four questions, right? I have told you there are last seven questions left from the projectile motion. So these seven questions which we are going to discuss in this video. Okay. So let's start with our first question. Perfect. So this is a pretty nice question. Okay. We'll consider this question in the hard category because there are a lot of concepts, okay, and I'm going to generalize the situation as well, okay. So first let's solve this question. Okay, a large heavy box is sliding without friction down a smooth plane of inclination theta, okay. From P, so look, this is a large and heavy box, okay. So heavy, it can have any mass, but in kinematics, uh, we actually do not need about these masses. Okay, from the point P on the bottom of the box, on the bottom of the box, it is saying. Okay, so remember, this is our inclined plane, this is our angle theta, and let me make the box like this. So this is the bottom of the box, this is our box, okay, and this point is like P. From here, it is projected. Whether the initial speed of the world with respect to box is u. So with respect to the box, it is u. Okay, so this point is P. Let me rub it. Perfect, right? So remember this. This is the bottom of the box and this is point P from where it is projected. Okay, and u is the relative velocity with respect to box, right? So and this angle is alpha. The direction of the projection alpha. Okay, perfect. Find the distance along the bottom, it is asking, of the box between the point of projection P and the point Q where the particle lands. So let's say it is landing here. This is our point Q. And now the distance along the bottom of the box is it asking. So the observer must be inside the box and it is calculating the distance or the range, to be precise, where the box where the particle q is landing. Okay, so what p will see is this motion. Yes, so p will see a simple projectile motion. Now you must be asking here that, sir, if p is here, there must be a acceleration g sine alpha here. The one acceleration g cos alpha must be here. G sine theta, sorry. So G sine theta and G sine theta and G cos theta, right? So G cos theta is here. There is no issue with that, but G sine theta will not be there. Why? Look, this box is moving with an acceleration G sine theta. It is sliding down the inclined plane, right? So when I and let's suppose this box has a velocity v. Let's say, right? From the outside, I'm saying this box has a speed v here, and it has an acceleration G sine theta. Okay. Now, and what about this particle? This particle will also have u in this direction, but it will also have v in this direction from the outside. Okay, so let me make the situation a bit more clear for you. Now, look, first let's observe this box from outside, from ground. Okay, just the box. We are looking at just the box. Okay, let me rub this part. not the book, it's the box. Let me, we are observing. So observing, observing box here, okay, from the ground. So we are here. Now what we'll see, this box has an initial velocity v and it has a acceleration here g sine alpha, g sine theta, right? Because this is theta, right? So it will have an acceleration g sine theta here, only this. Perfect. Now, when I start to observe particle from where? Outside. So from ground. What we will see is this is the base of the box. This is our inclined plane. So particle is here. It is going with u at an angle alpha with respect to box. But as the box has initial velocity v, so this particle must have initial velocity v here. Are you getting me? That's it. Now, as soon as it leaves this base of the box, it will have g sine alpha here, g sine theta to be precise. Yeah, g sine theta will be here because incline has an angle theta, and it will have g cos theta here. Okay, so from outside we see this particle going like this. Yeah, so it is going like this. Okay, so I just exaggerated it a little bit. So let me make this. So it will have this. Okay, right? Perfect. So it will have like this. So from box perspective, we will exactly see a perfect projectile motion. But from ground perspective, the projectile will look like this. Are you getting me? Perfect. So let's do our first part of this question, A part. Yes, what is saying? Find the distance along the bottom of the box between the point of projection P and point Q where the particle lands. Assume that the particle does not hit any other surface of the box. Neglect that. So clearly we have to write the range, this PQ with respect to box itself, right? So PQ will be what? PQ will be what? So if I'm looking at like this, we will have a simple projectile motion. Yes, so this will be P, this will be Q, and we have thrown it with U at an angle alpha. So particle will go like this. So what range will be? Now remember, this is not G, this is not G, it will be G cos theta. And here there is no acceleration. So G sin theta will not be there because we are looking the particle with respect to box. Okay, so what will be the range here? Yeah, it's a simple. Yes. What will be the range here? It will be u square, right? Sine 2 alpha divided by g cos theta, right? So this will be our answer. Okay. So first part was very easy. There is nothing you have to do in this, but the B part is actually interesting. Okay. So B part is actually interesting. Let's solve the B part. Now, to solve it, we have two methods. We have two methods. Okay. Let's first study this part. Now, what is saying? If the horizontal displacement of the particle as seen by an observer on the ground is zero. Okay, now we are looking it from the outside, from the ground itself. Find the speed of the box with respect to the ground at the instant when the particle was projected. So we have to find this v. We have to find the velocity of initial velocity of the box. We have to find v. Okay, perfect. So let's look this situation from these two perspectives. Okay. So if I start to solve this question from box perspective and from ground perspective, we will have two methods. Okay. So first one was very simple method, right? Now first method one, we are solving this question from ground perspective. Okay. Ground perspective, right? Let's solve. So what we will find that this is our particle. this is our incline, right? Now, if there is no horizontal displacement, means the net velocity of particle must be in this direction, in vertical, right? Let me make the diagram. So particle will go like this, right? Particle start from here, go like this and go down, right? So let's just solve here. Now we know this is the u, this is angle alpha, and this is v. This is the velocity of box, right? But as we are looking it from here, we are looking the situation from ground, so we must add this v. Okay, so we will add acceleration also, but it does not matter. Let's add it, g sine theta, and it here will be g cos theta. It does not matter actually. Now look, if the particle is moving in this path, right? So horizontal velocity must be zero. So let's equate the velocity in this direction. Okay, let's equate the velocity in this direction. Let me make a line here in this direction, right? So look, now if this is angle alpha and this is angle theta, so here it we will have a component u cos alpha plus theta, and here it will be, yes, u sine alpha plus theta, right? Now v, if this is horizontal and this is inclined, so this is a theta angle, so this must be theta, right? So here we will have, let me rub this part, okay, right? And this was our theta. So here we will have v cos theta, and here we will have v sine theta, right? So this and this must be zero. So v cos theta must be equal to u cos alpha plus theta. Means the component, this component must be equal to this component. Then and only it will be doing this vertical motion, right? So that directly we will get v equal to u cos alpha plus theta divided by cos theta, right? So this is quite simple, but uh, this method is not so convincing, right? Now let's move on to our method 2, which we are going to solve from what? From a box perspective, from box perspective. Okay, let's solve it. Now look, let me make a diagram. This. Okay, this is our box. Okay, let me make 2 point. One is this P, another is this Q. Let's say this is A, let's say this is B, and let's say this is C. Now try to understand this. These A, B, C points are uh, on this inclined plane, and P, Q are the points on box. Okay, so when I throw this particle and I'm looking it here, right? No matter what is V, no matter okay, so it will be sliding with an acceleration g sine theta, right? So no matter this V is, the particle will always reach at Q, right? Particle will always reach at Q. Now look here. When I look this situation from outside, okay, if this V is zero, then definitely what we are going to see, if V is zero, I don't know what will happen, okay, but look, if this V is something, right, the box will slide here. So what happens is this Q will go here, right? So the situation will look like this. So this is A point, this is our B point, this is our C point. If the box is at rest, then the particle will be at Q, and we will see it just above the C, right? But what happens is this, right? So this is our Q, this is our P. So particle will be here only, Yeah, it started from here, but it will reach here, right? Between B and C. That is why from outside we have seen the particle like this, right? It from inside it was like this, but from outside the particle projection was like this. Are you getting me? Now look, if I put this V such that this Q point will reach A, this Q point will reach A. That means, look here. Okay, let me make the diagram with this pen first. Okay, look. So this is A, this is B, and this is C. Now, what happens if this box we are looking at is like this? Okay, yeah. So P is like here, and what happens if this box lights such that this Q point will just exactly on this? So what we'll see, if the particle is projected, no matter what the speed is, but it goes like this and comes like this. So we will see like this motion. So this will see, right, from the outside. Are you getting me? So this shows that there is no horizontal displacement and even no vertical displacement also. Net vertical displacement will be zero and net horizontal displacement will be zero, right? So let's solve. Now, how will solve this from the box perspective? Look, from the box, the particle has traveled the distance r, which we have calculated, right? And it has taken some time. We can find this time of projectile. What it will be? It will be simply u, 2u sine alpha, right? Okay, so let me solve it here. Right. From the box perspective, what is happening is, from the box perspective, the particle has traveled u square sine s 2 alpha divided by g cos theta, right? And that time of flight was 2u sine alpha divided by s from the box perspective, right? It is going like this. It is reaching, it will always reach at q, right? If the box is moving with an acceleration g sine alpha, g sine theta, right? So here the acceleration was g cos theta, right? So we will write g cos theta, right? Now, what I say is, this was point C, right? This was point. What I say is, this the base of this box, this point Q, which is on the box. If during this time it goes like here, it will come at here, A, right? So we will see Q above A, and the answer will be fine, right? We'll get our answer. So how is solved? Look, now the box has to travel this r distance. It has an initial velocity v here, right? And it has acceleration in this direction g sine theta, right? That's all. Simple. So u for the box is v, right? So let's solve. We use s equals to ut plus half at square. So s is what? It's r itself. U is what? V, and time will be this. So time will be 2u sine alpha divided by g cos theta plus half. Why plus? Because u is in this direction, right? And g is also in this direction. So we'll write g sine theta into t square. And t is what? T is what? So t is what? 2u sine alpha divided by g cos theta. And r was what? U square sine 2 alpha divided by g cos theta. Now let's start to equate it, okay? So we will get u square, let's write it as sine 2 sine alpha cos alpha divided by g cos theta will be equals to This is V, remember this. V, this is 2 sine alpha divided by G cos theta plus half. So this is G sine theta, right? This will be 4 u square sine square alpha upon G square cos square theta. Yes, it is taking a bit time, but this solution will be like good, like you're getting the situation what is happening here. So one you will get cancelled. Okay, so 2, it will be 2, right? So 2, 1 sine alpha will also get cancelled here, right? 1 g cos theta will get cancelled here, right? So we will have here, we left with u cos alpha is equals to, here we will have only v, right? Only v. Okay, perfect. Plus here we will have, okay, so 1g we have already cancelled, and 1g will get cancelled here. Okay, so there is no g, so it will be sine theta, 2 also gone. We have u here, we have sine alpha here, and we have cos theta here. Okay, now so from here we will get, u can come here, right? So we'll get v u cos alpha minus u sine theta sine alpha divided by cos theta, right? So we will have v as u cos theta cos alpha. We can just take LCM, right? U sine theta sine alpha upon cos theta. And this, look, this you can, we can take u as u common, right? So this is cos theta plus alpha. So we will get the same answer, u cos theta plus alpha divided by cos theta, right? So we'll have the same answer. It's the shortcut method, of course, conceptually good, but this solution gives us understanding. So look, I can generalize the situation. So situation is like this. From ground perspective, what we will see is this. Yeah. So what we'll see is this. This is our this, right? Okay, I don't need to make this. From here we are throwing the particle, right? And look, from here we have thrown it at an angle alpha, right? And this was the particle's velocity v, right? So here the component will be u sine alpha, and here the particle's velocity will be u cos alpha. Perfect. Now look, the acceleration in this direction for the particle will be g cos theta, because this is theta, and here it will be g sine theta, right? Now what we are changing, actually we are changing just v. So horizontal component of the velocity, I mean in this is our horizontal line, we are considering this as x and we are considering this as y. So horizontal, this component of the uh, particles, yeah, velocity of velocity, I'm sorry, the particles velocity in this direction is changing, right? But in the vertical direction it is still u sine alpha, right? And this is also constant. So particle will achieve its maximum height no matter what you do with the v. Okay, so what happen is, if suppose v is 0, then the particle will be like this, right? But it is going like this, so particle will be somewhat like this. Then what happens is, it will be here and it will go here like this, right? But at some moment particle will go like this, and particle, for this moment, for the second part, particle will go like this and this. And as v is increased, situation will be like this, right? Are you getting me? So these are the possible paths which we'll see from the outside. So this is a generalization of this question, right? So this question is actually very good. That is why I'm considering as a hard problem, right? The solution is very simple. It's like one-liner solution, but the concept is very deep. Okay, let's move on to our second question, shall we? So this is going to be our next question. Let me adjust it. Oh, now what is this question is saying? An object A is kept fixed at this point, okay, on a plank raised above the ground. So the height of this plank is like negligible, okay. So the A is already here. At time t equal to 0, the plank start moving along x, okay, with an acceleration 1.5. So it is starting means u is 0, right? Okay, with an acceleration 1.5. At the same instant, a stone is projected from the origin with the velocity u as shown. Okay, so this theta we don't know, right? The stationary person on the ground. So we are observing this situation from the ground. Observe the stone hitting the object during its downward motion, okay, at an angle 45 degree to the horizon. Okay, find u and the time after which the stone hits the object. So situation is like this. Situation is like this. This particle is projected with u at an angle theta. We don't know that this theta. And what is happening is it will do its projectile motion like this, right? But what happens is this A object is traveling with some acceleration and it will reach here when the particle is moving here with the velocity and it is making an angle 45 degree. Yes, so here it is, we don't know this V. And this particle, let me rub it a bit. This A is moving with an acceleration which is 1.5 meter per second. Now we have to find the time, right? And U we have to find. This is U, okay? This is U. We also have to find U vector. Perfect. So we have to make the equations. Okay, it's complicated. Let's so so first let's write the equation for this. So it has U0, right? So let's say it covers a distance x. In the horizontal, it will curve because it is moving in the horizontal. So we'll use x is equals to half acceleration 1.5 into t square, right? So this is our first equation. Let's remove the decimal. Okay. So it's 15 by 20, so 3 by 4. So x will be 3 by 4 t square. Now, this is for the particle A, for the object A, right? For the object A. Now, okay. Now we are going to write equations for our projectile. Okay. Projectile. We have. Now look, this distance is 3, right? So in horizontal, we know it will always have u cos theta, and in vertical, it will have u sin theta, right? So in horizontal, it is covering 3 plus x distance, right? With the speed u cos theta, and for the time t. That is a simple equation. Let me write t as this. Okay? Because in horizontal, there will be no acceleration. This is our second equation. So this is first, this is second. Let's write another equation. Okay, now we know for a fact that this distance is how much? It's 1.25 meters, right? So this, if I write the second equation for y, let's write. So Sy will be uyt plus half ayt square. So Sy will be plus 1.25, uy will be above u sine theta into t plus half. Acceleration will be minus 10 into t square, right? I'm taking 10, right? Let me write g. So we will have 1.25 equals to u sine theta into t minus g is 10, so 5 t square, right? So this equation, this is our third equation. Okay. So how many variables we have? Let's write them. So we have x, we have t, we have u, we have theta. We have only four variables, but equation is three. Right? So we need more equation. Okay, look. So this is v, and this here is always u cos theta. So for horizontal, we can write it as v sine 45 must be equals to u cos theta. This is our fourth equation, right? Because in horizontal there is no acceleration. But due to this, we have another variable. So another equation we need, right? We can write first equation in y, right? So let's write Vy will be Uy plus Ayt. So Vy is what? It will be V cos 45 is equals to Uy is what? U sine theta. Now Vy will be in negative direction, right? It will be in downward. U sine theta is above, plus acceleration will be minus g into t. So from there we'll get minus v cos 45 will be equals to u sine theta minus 10t. We'll get another equation. So this is our fifth equation. Now the situation is easy. Let's solve. Let's remove the excess variables one by one. Okay, so what we can do, we can divide 4 by 5. Let's do that. 4 divided by 5, equation 4 divided by equation 5 will get this v cancel, this will get cancelled, so it will be minus 1 will be equal to u cos theta upon u sine theta minus 10t, right? So we have eliminated v. Now, can we eliminate x? Let's put x here. So we will have from first and second, we will have 3 plus x. In the place of x, we can write 3 by 4 t square will be equals to u cos theta into t. All right. So we have used this equation, we have used this equation, we have used this, and we have used this. So we have this, this, and this. We have three equation and only three variable must be there. So t, u, and theta. Perfect. Okay. What can we write here? So let's rearrange this a bit. We will get from here will be u cos theta will be equals to 10t minus u sine theta, right? So we have here, let's arrange this also. We will have u sine theta into t will be equals to this 5t square will come here. So 5t square plus 1.25. Yes. So we have u cos theta t into u sin theta. So let's multiply it by t. We will get u cos theta into t is equals to 10t square minus u sin theta into t. Right? Now let's put this here and this here. Okay. So we'll get 3 plus 3 by 4 t square equals to 10t square minus 5t square plus 1.25, right? Perfect. We will get, so 3 by 3 by 4 t square will be equals to 10t square minus 5t square minus 1.25. Let's rearrange them. So this will come here. It will be 4.25 and this is 5t square minus 3 by 4 t square. So we will get 4.25 will be equals to 20 minus 3. It will be 17 by 4 t square. So 17 by 4 will be 4.25 itself. Yes, so we will get t as 1 second. Yes, right? we get t. What another thing we have to find? We have to find u. So if we have t, we can find u very easily. So look, this u sine theta is what? So u in x is what? U cos theta, right? So u sine theta is what? It's a component in y direction, right? So just simply put the values here. We will get first u cos theta, t is 1 1 1, so this is 1, so it will be 12 plus 3, 15 by 4 meter per second, and u sin theta will get 1, so this is 1 1 6.25 meter per second, and 15 by 4 is what? It will be 4, oh no, it will 3.25, right? 3.75, sorry, 3.75 meter per second. So we will have u vector as 3.75 I cap plus 6.25 j cap, right? So this question is actually very easy, but it's a bit lengthy, right? We have to write 5 equations, then we have to eliminate those variables. So it's a bit lengthy, so I consider it as a moderate one. Okay, let's move on to our third question. Let's move on to our third question. Right. So there are two guns. Okay. Situated at the top of a hill. So let me make a hill like this. Right. So we have a gun. At a height 10 meters. So this is 10 meters. Fire one shot each with same speed. Both guns at some interval. Okay. So one at supposed to equal to 0. Another hit at another shot at T naught. Okay. Now one gun fires horizontally, so one gun is firing this as like this, so it will go like this, right? This bullet will reach. Another at upward, okay, so another fires like this, okay, but at an angle 60 degrees, so this will be like this. We don't know, maybe here or I don't know, right? They might hit. The shots collide in a air, but yes, okay, so they must be hitting. Find the time interval between the firings. Okay, so let's say, okay, look, one thing is clear, they're both x and they're both y will be same, right? So bullet one, we write equations individually, and for bullet two, we'll write equations individually. Okay, so like this was our horizontal one. Okay, this was horizontal. This was at theta equal to 60 degree. Perfect. Let's write for equations for bullet one. Now look, it is covering horizontal distance x. Now there is only this 5 root 3 component here, right? In the horizontal direction. So ux is what? 5 root 3. Let's say it is taking t time to reach here. So it will be what? We can write r, which is x, is equals to ux 5 root 3 into t time it is taking. Let's say horizontal acceleration is 0. Now for the y, we can take this as negative and above as positive, right? Now for y, we can write minus y will be equals to y initial 0 plus half. Acceleration will be minus 10, let's say 10 into t square. So we will have y will be equals to 5t square, right? So we have these two equations. Okay. Now let's say after so look, this bullet is released at t equal to 0. So this must be released at t equal to t naught. Okay. So I just have to add in the time I have to add t plus t naught. So let's write for the x, we will have x component will be ux component will be 5 root 3 cos 60, right? So it will be 5 root 3 cos 60 is 1 by 2. So x will be 5 root 3 by 2 t plus t naught, right? Now you must be saying, sir, bullet 2 may be uh, short at t equal to 0, but bullet 1 is short at t equal to t naught. No matter what, if this is the opposite situation is there, then t naught will automatically come out to be negative. Okay, don't worry about it. So, okay, though, so t naught will get negative, don't worry about it. So we have this equation, right? Perfect. For the y, we can write simply, so uy will be 5 root 3 sine 60, right? So it will be 5 into 3, 15 by 2 will be, right? That's right. So minus y will be equals to 15 by 2 into t minus half g is 10. Okay, so this time will be t plus t naught, right? T plus t naught. T plus t naught. This will be t plus t naught. Okay. So we have four equation and four variable. We can simply solve them. So let's solve this. Equate both of them. So we will have from 1, this is 2, this is 3, this is 4. So from 1 and 3, we will have 5 root 3t will be equals to 5 root 3 divided by 2 t plus t naught. So this will get cancelled. So it will be 2t will be equal to t plus t naught. So we will have t equals to t naught, right? Okay. Now let's put this here. We will have 5t square minus 5t square will be equals to 15 by 2. 2t I can write minus 5 2t whole square. So we will have, this will get cancelled. Minus 5t square equal to 15t minus this will be 4. 5 2 20 t square. So it will come here. So 15t square, right? 20t minus 5 will be equals to 15t. So we will have simply t as 1 second again. Yeah, what a coincidence, we are getting t is equals to 1 in each and every question, right? Okay, perfect. So if we have t, we'll get t. In the second point, we have find the coordinates of p. Take the origin, take the origin of the coordinate system at the foot of the hill right below the muzzle. So this is the foot of the hill. I have to take this as 0, 0. So look, first let's find x. So x will simply be 5 root 3, right? So this is 5 root 3 and what is y? Y will get 5. So this is 5, right? But look, this is 10. So the coordinate will be, this is 5, right? And this is 5 root 3. So p coordinate of p will be 5 root 3 comma 5, right? So we got. So it's an easy question, nothing to worry. Very simple question it is. Let's move on to our fourth question. Fourth question. Oh, it's a pretty big question, no? Don't get scared. Let's see. So A, B, and CD situated at a distance t. AB is 20, so this is 20, this is 30. An object of mass m is thrown from the top of the horizontal with the velocity 10. So we have thrown it as 10 meter per second. Simultaneously. Okay, so in before question, they were shot at different speed, different time, but these were shot at different at the same time. Okay. Okay, this has mass 2m. So this is m, this is 2. Okay. So I think we have to use Newton's law a little bit. No worries. Thrown from the CD at an angle 60 degree with the same magnitude of initial velocity. Perfect. So the two objects move in the same vertical plane, collide in midair. Okay. Now look, situation is like this. This is our one tower. This is our another. It's going like this. It will move here and it might hit like this. Okay. Now this we have thrown it like this. Okay. It will be moving like this, and it might hit like this. Okay. Now let's say they are the though they are hitting at an x distance from AB tower, so this must be d minus x, right? Perfect. So let's write the equation first such that we get the d. Okay. So this is 10 meter per second. This is 60 degree. This is also 10 meter per second. Okay. This is 20 meter and this is 30 meter. Now look, this particle, let's say it's going x and downward it is going y. Okay. So this is y, this is 10. So this particle is going 10 plus y, right? 10 plus y. Okay. And for x, it is going here d minus x, right? So we have to use this. This is x, this is y, this is d minus x, and this is 10 minus. So for a particle on AB, we are writing different equation, and for particle on CD, we will write different equation. So let's just write them. So x will be clearly what? 10t, right? And the y will be minus y will be equals to 0 minus half into 10t square. So y will come out to be 5t square, right? We have these two equations. Let's write for it. T minus x will be the horizontal component will be 10 cos 60. So cos 60 will be 1 by 2. So it will be 5 into t at the same time we are talking about. For the y, it will be minus 10 plus y. Minus 10 plus y will be, so here it will be 10 sine 60, right? This will be uy. Sine 60 is root 3 by 2, so it will be 5 root 3. So it will be minus 5 root 3 into t, okay? Because it will be in the downward. And g is also downward, so it will be plus half minus 10 t square, right? So it's the same question. We have done it. Let's, so minus will get cancelled. So 10 plus y will be equal to 5 root 3t. The equation, to solve this equation, it's similar to the one which we have done it, which we have done before. So let's put x here. It will be, so from 1, this is 1, this is 2, this is 3, and this is 4, right? This is 4. So it will be same, right? So from 1 and 3, from 1 and 3, we will get t as 15t. Okay, so we will get t as 15t. Let's put this. So we will get from 2 and 4, we will have 10 plus 5t square will be equals to 5 root 3t plus 5t square. So 5t square got cancelled. So t will get 10 by 5 root 3, which will be 2 by. So we have t. So we can put t here. So d will be 15 into 2 by root 3. So it will be 30 by root 3, which is 10 root 3 meters. Yes, so we'll get t. Now find the position where the object hit. Find the position where the object hit the ground. Okay. Is there another information? Collide midair and stick to each other. Okay, so they basically stick to each other, right? So we have to use conservation of momentum. Okay, let's solve the B part. Now look, we first have to find the final velocity with which they are coming. towards each other. Okay, so let's find the final velocity, shall we? So for particle 1, the final velocity will be like this. So we will write v vector as u vector plus a to t, and so, and for other particle p2 we'll write v vector as u vector plus a vector plus t, uh, to t, right? They stick to each other. Okay, look, the conservation of momentum should be such that now on this p1 particle there is g downward, okay, and f will be here, right? So mg will be here. On this other particle 2mg will be here and f will be here. This f is due to collision, okay? Now if I'm taking this as a system, then horizontal momentum is only conserved, right? So horizontal momentum I have to write only. Horizontal velocity I have to write, right? So let me rub this. So what should I write here for the second part? That we have to apply we have to apply conservation of momentum, conservation of momentum only in horizontal direction, horizontal direction. And we know the horizontal particle of both, horizontal velocity of both the particle. So ux for one was what? 10 meter per second, and ux for two was, it was 5, right? It was 5 meter per second. Okay, so mass of one is m and the mass of two is 2m, right? Let me check m and 2. Okay, perfect. Now let's write m1 ux1 plus m2. Now look, this particle is going here, so let me write this as minus m2 ux2 will be equals to m1 plus m2 into Vx. We'll get the final velocity in Vx only. So this will be m to 10 plus 2m into minus 5 equals to m. This will be 3m to Vx. So we will have 0. So Vx will get 0. Means when they collide, they only their horizontal velocity will be 0. X will be right. Are you getting me? Right? So they will not have any horizontal velocity. That means when they combine, let me enter the figure. So when they combine, they just drop here. So where on the ground they will drop? So from AB tower, they will reach at X. So X we know, right? What will be X? So X was 10t, 10 into 2 by root 3, which is 20 by root 3. So this will be the answer. Yes. So this question was again the easy one, right? And we have just solved this the same type of question just above. Okay, this was an easy one. Next, let's move on to our. We have done four, right? Let's move on to our fifth question. So this is our fifth question. Perfect. Now look, the particle P and Q. Okay, again, this particle has mass m and this has mass 2m. Again, we have to use something like that, right? And be moving initially velocity of particle P and so if this is 135, this must be 45. Okay. Find the horizontal with the horizontal AB. Each particle has an initial velocity 49. Okay, so situation is like this. This particle is projected with 49 and it will move like this, right? Now, another particle from B is thrown like this. Okay, so they will go like this. Okay, let's first find the range of this. Okay, the distance between them is 245. Look, the situation will be very simple. If the range of A, I mean particle P, is 245, let's first find this. So this is 45 degree. G we have to take 9.8. So range was u square sine 2 theta divided by G. So u square will be 49 into 49, and sine 2 theta sine 45 will be 1. 45 to 90 sine. So sine 90 will be 1, and G will be 9.8. So 98 into 10. This will be 2. This will be 5. 49 5 ja 5. Yes, so 245 it is coming. So this particle must be here, and if we throw it like this, they must collide midair, right? When they achieve their maximum height, they will collide just here, right? After the collision, P traces its path. So after the collision, like look, if this is our P, this is our Q. P is coming here with a velocity u cos theta, and if it is retracing it back, means it must go back with the same speed, which is u cos theta. Then and only it will retrace its path back. Okay, and now at this point, both have uy component will be 0, right? So we just have to conserve momentum in the x direction. And then we'll find the velocity of this, and we will know how much time it will take. Okay, so it's an easy question. Let's solve it. First, conserve momentum. So it will be m u cos theta, right? And this is coming with minus 2m, the same speed, 2u cos theta, but in this direction. This is for the particle 1, this is for particle 2, and after that it is going in the opposite direction. So it will be minus m u cos theta plus will be 2m v. This v will be fine. So it will be minus m u cos theta be equals to minus mu cos theta plus 2mv. So it's exactly same like this, right? So v is 0 means the q particle will just drop down. Okay, so it's a simple situation. This is q, this is our h. So h we know. H is what? U square sine square theta divided by 2g. Let's first find this. So 49 into 49 sine square theta will be 1 by 2 divided by 2 into 9 8 into 10. So this will be 2, this will be 5. So it will be 49 into 5 divided by 4. Okay, I'm not solving it, just let it be like this. Now I have just find how much time after the collision does particle Q will take time to reach the goal. So we know the time period when the velocity is 0, initial velocity is 0 and just drop down. So you should remember the formula. Time period will be 2u by uh, 2h by g, right? So we'll write just 2h. H was 49 into 5 divided by 4 into 9.8, so 98 into 10. So we will have, this is 2, this is again 2. So we will have time period will be root 50 by 4. So this is 2, this is 25. So root 25 by 2 will be 3.3, 3.53. Yes, 3.53. Yeah, answer is correct. So 3.53 seconds will be the answer. Okay. So this is an easy question again. Nothing to worry about. Just find the range and then you'll know. If the range was different, then we would have solved it differently, but this was an easy, comparatively easy question. Let's solve our sixth question. Okay, perfect. Now, sixth is our true false, so it should be easy. A projectile fired from a ground follows a parabolic path. The speed of the projectile is minimum at the top of the. So this is true, right? We know this is the basic of projectile motion, right? Okay, perfect. Next, the the trajectory of the projectile in the vertical plane it's is given as this. So why we have ax minus bx square. Okay, so we know the equation of trajectory was y equal to x tan theta 1 minus x by r, right? So if I rearrange them, so x tan theta minus x square by tan theta by r, right? So let's compare them. We will have a will be equals to tan theta, and we will have tan theta by r is equals to b, and tan theta is a, so r will be a by b, right? Okay. Now the maximum height attained we have to find. Okay, so the formula for maximum height attained was u square sine square theta divided by 2g. Okay, so let's first write the formula for range. What was it? U square sine 2 theta, we can write sine theta cos theta divided by g. Let's divide both of them. Okay, so we will have h by r will be equals to u square get cancelled, g will get cancelled, 1 sine theta will cancel it. So it will have sine theta by cos theta divided by 4. So sine theta divided by cos theta into 4, right? So h r was, we can put a by b. Okay, so it will be tan theta by 4, right? So let's cross multiply this. So we will have h will be equals to a by b tan theta divided by 4, right? So what? So tan theta was a. So we will have a square by 4b. Yes. Because h we have to find in terms of a and b, right? We do not have tan theta, we do not have so I have to find this. So this is, we got the angle of projection from the horizontal. It will be simple, right? So theta will be tan inverse of a. Yes. A we know, so tan inverse we can find. So it's a easy one, right? Very easy. Okay, perfect. So these were our sixth and seventh question. That is the end of our chapter kinematics. Okay, so for the circular motion, I will be covering them in the laws of motion. Okay, so this is the ending of our chapter kinematics. So let's end the today's session. Thank you.